Now we're doing freeCodeCamp, JavaScript algorithms and data structures, functional programming, introduction to currying, and partial application. All right. So the arity of a function is the number of arguments it requires, right? So this would be an arity of 2, I would imagine. So currying a function means to convert a function of in-arity into in-functions of arity 1, all right? So in other words, it restructures a function so it takes one argument, then returns another function that takes the next argument, and so on. So here's an example. Here's the uncurried with the arity of 2, where it's got 2 arguments, x and y, and then we're going to do x, we're going to return x plus y. And then here's the curried function, which has the curried, and then it's got x, and then it has a callback function inside of it that is looking for y, and then we can do x plus y, all right? So I'm going to tell you right now, out of doing all those Code Wars videos and all those Code Wars problems, I only ran into this one time. It seems like nobody, at least on Code Wars, does currying, but when I did get to it, I had no idea what was going on. All right. But anyway, and this is kind of hard to wrap your head around, but if you just look at it as is, it does. I mean, I don't know if it really makes sense, but it works. And as long as it works, we can figure out the whys later. That's the main thing for this whole freeCodeCamp thing. So here's the ES6 style. We can do const curried. It's the same as this. Const curried equals x, and then it has an arrow function, and then we can say y, and then another arrow function, and x plus y. And then so when we do curried, and then 1 like this and 2 like that, it'll return 3, all right? So this one goes for the x because that's the first one, and then this 2 goes for the y. That's the second one, all right? And like I said, it's real hard to wrap your head around. I still don't even really understand the whys about it myself, but I do know that it works, so let's just keep going. So this is useful in our program if we can't supply all the arguments to a function at one time, right? We can save each function call into a variable, which will hold the return function reference that takes the next argument when it's available. So here's an example of using the curried function in the example above. So we say const func for y equals curried 1, right? So that puts in the x a 1. So later, if we find a 2, we can say func for y, which at first it's curried 1. When we do func for y2, it adds the 2 to it. So here's the x, right? And then later we find the y, and now this is going to give the console log of 3, all right? So this is the x, this is the y, and you know, there's not too many ways to practice online for this, but it's good to just understand it, in my opinion. So similarly, partial application can be described as applying a few arguments to a function at a time and returning another function that is applied to more arguments. So here's an example. Here's a function impartial. We've got x, y, and z, and then x plus y plus z. And then here's const partial function equals impartial dot bind, and then this, and then 1 and 2, all right? So I've never seen bind before looking at this lesson. So let's just come up here. I didn't even know it existed, honestly. We'll say bind method in JavaScript, and let's read about it right here. So the bind method of function instances creates a new function that, when called, calls this function with its this keyword set to the provided value, and a given sequence of arguments preceding any provided when the new function is called, all right? So I don't really know what that means either, but basically it's just gonna have this right here, and then however many arguments afterwards. So we'll come down here and do the impartial.bind. We've got this, which is gonna be the x, and then 1 and 2, pardon me. And then so we've got the this is now the 10, all right? That's the this that's missing is the 10. So I don't know. I wonder if we can, I don't know. Anyway, so this is kind of confusing too. But anyway, we've got the 1 and 2, and then we put the 10 in later. That's going to be when we do this function call, and it's going to equal 13. So the 10 plus the 1 plus the 2, all right? So as usual, that's pretty much all they're going to give us on this. And this is pretty hard to understand. I don't know, maybe you can understand, but I could read this a couple more times and still not get it. Especially since there's no real, I mean, we could read this, but no way. So anyway, we're going to fill in the body of the add function. So it uses currying to add parameters X, Y, and Z, right? And it doesn't even go into impartial. So that's what we get, right? So let's get into this. And so what we're going to do here, we'll just mix up the two styles, right? We'll mix up this style and, this style and this style. So we'll say here, let curried equal, and since we're looking for a Y and a Z, all right, we'll do it sort of like this. We'll say Y and then the arrow, Z arrow, whoops. And then we'll say, what should we say here? X plus Y plus Z. X plus Y plus Z. And then since we're doing it this style, we'll say return curried. All right. And that should take care of it. Let's wrap this thing in parentheses. It should give us 60. And then say console.log, console.log. And you see it does say 60. If we change this to 2, it'll give us 32. So it does work. Like I said, I don't even know where to find any examples of this in the real world. But I'm sure like if we go on a ChatGPT or something like that and we really, really need it, we can find it. So that's pretty much that. And let's run the test. Looks good and submit it. All right. And so that's the end of functional programming. I'd say it's a lot of pretty good information. This introduction is pretty horrible, but what do you expect, right? Because I mean, clearly there's going to be no more of that after that. So whatever. But anyway, so now we're on to intermediate algorithm scripting. As you can see, I stopped at 12. This one I start like right when I got to the 12th one or the 13th one, I was like, you know what? I'm going to start doing Code Wars because I do not understand this, you know? And this is my second time through, by the way. The first time I just went with hints the whole time and never got anything out of it, right? So now we're on to intermediate algorithm scripting, and we'll see you next time.